We don't always graph inequalities on a number line. Sometimes we graph them on an xy axis when we have two variables with an x and a y. So I'm going to look at how to graph a linear two-variable inequality today. All right, and just like when we're graphing a normal line, you can really think of this first example here as y equals 2/3 x plus 1, and for the most part it's going to stay exactly the same as graphing a normal line minus maybe one or two differences that we'll talk about. Okay, so I'm going to start graphing this line by going to 1 on the y-axis, and then just like using slope-intercept form, I'm going to go up 2 over 3, up 2 over 3, and I can also go down to backwards 3 here. It's good to cover a good bit of the graph when you're doing these problems. Okay, now here's the first difference. When I have just a less than sign or a greater than sign, so if it looks like this or this, you're going to graph a dotted line. Remember that when you're graphing these on a number line, when you had a less than or a greater than sign, what you were saying is that you could go everything up until that point. Like if you had x is greater than 1, everything back to 1 is okay except for 1. We couldn't include 1 in our solution, and that's kind of where this is going here too. If I'm graphing a two variable inequality, we're saying that anything on one side of the line is okay, but if we don't shade the line in and we make it a dotted line, points on the line are not in our solution. Okay, so I put a dotted line here to represent that. It's sort of like having an open circle but in two dimensions. Okay, so now that we've got our dotted line, we just have to decide which side of the graph to shade on. Okay, so I'll look at y is less than 2/3 x plus 1. I'm going to start by testing a point here on either side of the line, because when we're graphing a two-variable inequality, we're either going to shade the points above the line or shade the points below the line. So for this example, I'm just going to pick this point right here. You could pick any point you want. You could pick like 4, 1, you could pick anything. I'm going to pick 0, 0 though. And to test that this point is in the shaded area, I'm going to plug that into the inequality. So I'm going to plug in a 0 for the x and a 0 for the y, so that'll be 0 is less than 2/3 times 0 plus 1. And then if I plug that in, this will all become 0, so I get 0 is less than 1. And 0 is less than 1 is a true statement, which means that the point that I picked over here must be in the solution because it's a true statement. So I'm going to shade on the side that that point is on. Okay. Now, if you look here, if this was not a true statement, if I got something like, 0 is less than -10, then I would actually see that this side would not be on the solution, and I'd have to shade the upper half of the line over here. So if it's true, we shade on that side. If it's not true, we shade on the opposite side of the line. And what this means is, so what this shaded area means is if I were to just pick any random point in this shaded area, like let's say this would be 1, 2, 3, 4, 5, 6, 0, that is in the shaded area. And if I plugged 6 in for x in here and 0 in for y, it should make a true statement. Okay? If I picked any point up here, it should make an untrue statement because that is not in the shaded area. Okay, so and I'll leave that to you guys. If you plug in a 6 for the x and a 0 for the y, it should be a true statement. So we're just trying to find out which points on this graph will make this two-variable inequality true. Now I have another way that I'll show you to shade these in a second, but this is kind of the introductory way that usually people are taught. Okay, it's plugging in a point on one side of the line. Okay, we'll try the next one. Just like before, we should put this in slope-intercept form. So I'm going to subtract 2x on both sides to get the y by itself. So we get -3y is less than or equal to -2x plus 6. And then finally I'm going to divide by -3 on both sides, which gives me y. Now notice, one thing to note, we divided by a negative number. I've got to flip that inequality sign around, and this should be positive 2/3 x minus 2, and there would be the slope-intercept form for our line. So let's go ahead and graph this. We're going to start at -2 on the y-axis and rise 2 and run 3. And I'll also go down 2 and back 3 just to extend my line a little bit more. And it likes disappearing the points for some reason here. Now when you notice this, this line has an or equal to line. So if it has the or equal to line, this is going to be a solid line. And what a solid line means is that when I put this line like a regular solid line, points that are on that line will make this inequality true. So if I pick the point 0, -2, and I plugged it in, it would make it a true statement. Okay? So we graph a solid line here. Now we just have to decide which side of the line to shade on. And an easier way, at least in my opinion, for linear graphs to do this is you can plug in a point. That's the one option I said. I could plug in like 0, 0 again and see if that's true or false and shade, based on that. But if you see a greater than sign, and it's got to be in slope-intercept form, so we can't tell from up here, but once you isolate the y, if you see a greater than or equal to sign, if you draw an arrow straight up on your line, that'll tell you which side to shade on if it's greater than. If it's less than, you're going to shade the lower half of the line. So if it's greater than, you're going to shade above the line. If it's less than, you shade below the line. So what we're going to do here is shade the upper half of the line. And I can do that without having to plug in a point. Okay, it makes it a little bit easier. It's a nice little trick for some people. And I don't always show that trick on the first day that I teach this. It's good to get in the habit of checking the points. But after, a day or so, then I'll show my students how to do that. We've got x is greater than -5. We'll do that next year. So this one is going to be one case where we can't use that special shading trick I just showed you. That's why I wanted to include this example. And if you remember, lines that have just an x are vertical lines. So I'll move this 5 to the left, and we're going to go straight up and down. Now remember, this cannot be a solid line. It does not have a little or equal to line underneath the greater than sign. So we've got to make it a dotted line, which means points on this vertical line are not included in the solution. Okay. And finally, I'm actually going to shade this with highlighter here, I think, just to make it a little better. What I'm going to do is decide which side to shade on. So again, since I don't really have an option here for shading above or below because it's a vertical line, again, I could try the point 0, 0. Now you might be a little confused here thinking, well, how can I plug 0, 0 into this equation? We don't really have anywhere to plug a y, but I do have an x that I can plug in here. So I'll plug in 0 is greater than -5. And remember, 0, 0 is over here. That does make a true statement, so I want to shade in the direction of the point that I tested. If it was an untrue statement, I would have shaded to the left of the line. Okay, so I'll shade over here. And then that should be my shaded area. Again, any point that you plug in there should work. Should work over on that right side of the line. Now, again, if you like shortcuts, when I see this is the one type of line that I don't think of as up or down, I think of as left or right. If you think of where are the bigger values of x, are they to the right or to the left of this line? And if you were to think here, you've got, -2, you've got, 3 over here, all the way over here, you've got 2, 4. So this looks like -6. Let me just double check. 1, 2, 3, 4, 5, 6. This would be -6 over here. You can see that the smaller numbers are to the left and the bigger numbers are to the right. If we have a greater than sign, we want to shade towards the bigger numbers, which are over to the right. Normally, on almost every example, it's an up or down problem. This is the one example where you'll shade left or right because it's a vertical line. Okay? And that's just a quick introduction to how to graph linear inequalities with two variables.